look at how to calculate this ABD matrix without using any website or anything. We'll use the MATLAB for calculating the ABD matrix. And yeah, so suppose if you have a laminate, which is 0, 90, then 0. Okay, so is a laminate symmetric? Is this a symmetric laminate?
Yes, sir.
It is a symmetric laminate. Okay, so have 0, 90 and 0. Okay, so this is the mid plane. So we have 3 layers. So this is one layer, this is the second layer, and this is the middle layer. So it is symmetric. Okay, so the other way of representing this would be 0/90 bar and then saying symmetric. Okay, so what does this mean? It means the same thing. Okay, 0/90. Don't repeat 90. Okay, so this is 0. Correct? Any confusion in this?
No,
okay.
sir.
Okay. So this is a symmetric laminate. So what are the expected things? What are the expected things for ABD before we calculate ABD? Can you guess what will be A16 and A26?
It should be 0.
It should 0. What about the B matrix?
Should be 0.
0, sir.
Should be 0. Then what about the D16 and
It should be 0.
6?
0, 0, sir.
0. Okay. So no coupling, no any kind of coupling. This is what is to be expected from this. Okay. So here, so this is the coordinate locations of plies in a laminate. Okay. So this is a mid plane, and you have this as the K layer, for example. Then this will be K-1, and the down one would be K+1. And from the mid plane, you measure the height of that. Okay, so this is HK, and this is HK-1. Okay, and this is the thickness of that K layer. Okay, so this is how you represent the laminate. Okay, from 1 to n layers. 1 to n layers. Suppose you take a layer as K, then what is HK and what is HK-1? So this is how it is represented, and this is the thickness of the layer. So you'll get to know more about it when we do the numerical. Okay, so I'll just show you the formula for ABD matrix, for calculating ABD matrix. So what it says is A matrix is the summation of K1 to n. Okay, so it is 1 to n. 1 to n is nothing but layers. Okay, how many of our layers are there in that laminate? That many. The summation of what is Q bar? Q bar is nothing but the, what is it, Q bar? What do you mean by Q bar? What do you mean by Q bar? Q bar is nothing but transformed reduced stiffness matrix, correct? Q bar is transformed
sir.
Yes.
stiffness matrix multiplied by hk minus hk minus 1 is nothing but the thickness. Okay, hk minus 1 is nothing but, if you look at the uh, diagram over here, you can understand hk from here to here is hk. Suppose if this is the layer you want to analyze, then this is hk and this is hk minus 1. So hk minus 1 will give you the thickness of that layer. Okay, so when you calculate the ABD matrix, so this is hk minus 1 can be written as the thickness. Okay, but you can't do that for here because these are squared and cube. I'll let you know. This A matrix, you can straight away take this as hk minus 1 as the thickness. Okay, so let's calculate the A matrix first. It's nothing but the summation of the transform reduced stiffness matrix multiplied by the thickness. Okay, the summation. Now the laminate that we have taken is a simple one, 090. Okay, so for that you have we'll assume it is a carbon fiber reinforced epoxy laminate. Okay, so E1 is 181 GPa, E2 is 10.3 GPa, and major Poisson's ratio is 0.28. Shear modulus is 7.7 GPa. And then what you need to do is you just have to calculate for 0. So it is nothing but the reduced stiffness matrix. Because it is 0 degree, you need not calculate the Q bar. You just have to calculate Q. Even if you calculate Q bar, it will give the same thing. Okay, so this is Q bar here. So other things are commented, so it's not in the program. So whenever you see a percentage symbol in the before the code, so it means it's not considered in the program. Okay, it's commented. So I'm just calculating the Q bar. I need not calculate Q bar for 0 degree because Q is equal to Q bar for 0 degree. Okay. So if I just run this, so I see that both are same. Okay. This is the reduced stiffness matrix and this is the transformed reduced stiffness matrix. Both are the same. Okay. So what I'll do is I want to calculate the uh, A matrix. Okay, I say A matrix is equal to, so I'll take it as so it is the summation. Okay, so it is a summation of say Q bar underscore 0. Okay, meaning Q bar at 0 degree. Okay, multiplied by the thickness. Okay, did we define the thickness? No. So each layer here is of 0.5 mm. Okay, each layer is say 0.5 mm. So the thickness is 0.5 mm. So the total thickness of the laminate is 1.5 mm. Okay, so each layer is 0.5 mm. So if you want to indicate the coordinates, okay, you want to indicate the coordinates, it will be like this. So this is 0, 90, 0, 90, 0. Okay, so this is the mid plane. Okay, so this is z equal to 0. Okay, z equal to 0. We'll take the bottom, the downwards, as positive. So z will be here. How much will be here? Z will be equal to point.
0.25.
0.25.
Okay, here z will be equal to 0.75.
0.5.
Okay, here z will be equal to minus
0.25.
0.25, and here the z will be equal to
Minus
minus
0.75.
0.75. Okay, so this is the coordinate system that we follow. Now, anyway, we A matrix is nothing but the thickness. Okay, so it is just the 0.5 mm. Okay, so here just multiply with 0.5. Okay, so this is q bar. Q bar at 0 degree. Q bar is nothing but q there at 0. Okay, uh, multiplied by 0.5 plus q bar. I want at 90 degree. Okay, multiplied by the thickness. Okay, plus again this same thing. Okay, because 0, 90, 0. So I put this over here. I just copy it and put this here. Now I want to know what is q bar 90. Okay, q bar underscore 0 will just define. Q bar underscore 0 is nothing but q. Okay, q bar underscore 0 is nothing but q. Okay, that we have defined now. We need to define what is q bar underscore 90. Okay, for that let's calculate. I'll just comment this A matrix for now. Okay, so I want at 90 degree what is q bar. So I'll put this, I'll change the angle from 0 to 90 degree and then run this code. So I get two matrix, that is q and q bar. Okay, so you see it's slightly changed now. It's not, both are not the same because 90 degree angle. So what you do is you define q bar underscore 90 is equal to, you just type this matrix. This is the q bar matrix for 90 degree. Okay, so just type this 10.3461 2.89620. Okay, and then 2.89621 181.81080, and then 007.7. So this is nothing but q bar underscore 90. Now we have both of these, so I can calculate A matrix from this. So I'll just calculate A matrix. So this is what I get as A matrix: 186.9838, 4.3443, 0, 4.3443, 101, 0, 0, 11.55. So you can see that A16 and A26 are 0. Okay, so this is how you calculate A matrix. Okay, let's go back to the um, do this. We'll check with the website thing. Okay, 0, 90, 0 was a laminate. Okay, and then next So it is carbon epoxy. E1 is 181. E2 I gave it as 10.3, 7.7, 0.28, thickness 0.5 mm. Okay, and then next. So here it is 187. Here it is 186.98. Just rounded off. Okay, 4.345. 101.3, 11.55. Okay, so this is GPA millimeters. Okay, so the unit is because those were in GPA and thickness was in mm, so it is GPA millimeters. So this reduced stiffness matrix is in the units of GPA and the thickness is in millimeters, 0.5 mm. That is what we have taken. So you get the A matrix. So this is how what you need to do is I'm not actually writing a easy program for the ABD matrix. I mean where you can just enter the angles and orientations and get the ABD matrix directly. But what I'm showing you is it must not become a black box. I mean, what I mean is MATLAB should not make it as a black box. Okay, so the program must be just we are using MATLAB to make the calculations easier, but you should understand what is happening in it. Okay, so if you just copy paste and then run the code, you get the ABD matrix, but you'll not know what is how it calculated. So I'm making the calculations little in the sense I take the values from the results and put in here and then get the A matrix. Okay, so this is almost like pen and paper, but all the calculations is taken care of. Okay, so 090, so you just had to put this q bar underscore 0 as q because q bar and q are the same for 0 degree, and q bar underscore 90 was you were supposed to find out. So after finding out, you entered this matrix, and then for the to calculate a matrix, it is nothing but this is the formula, the summation of all the q bar multiplied by the thickness. Okay, so this comes 2 times because 0, 0, 90, 0. Okay, so next is the B matrix. For the B matrix, the formula is this. Okay, hk square minus hk minus 1 square. Okay, 1 by 2 into q bar ij. Okay, summation of all these into the square of this. Okay, so we'll just do this now. So this is 1 by 2 is 0.5. Okay, 1 by 2 is 0.5, and then it is q bar underscore 0, q bar underscore 0 multiplied by it is if you see here, it is 0.75 square minus 0.25 square. Okay, so the bottom side, when you take, you always take the largest distance. Okay, 0.75 minus 0.25, 0.75 square minus 0.25 square. Okay, 0. Just a second, 0.75 square minus 0.25 square. Okay, so this is for the q bar at 0 degree. Okay, plus next is q bar underscore 90. Okay, at 90 degree multiplied by it is 0.25 square minus minus of minus actually minus 0.25 square. Okay, so I'll just tell you. So this is 0.25 square minus of minus 0.25 square. Okay, for this 90-degree layer, it is 0.25 square minus of minus 0.25 square. Okay, so that's according to the formula. And then once again it is q bar underscore 0 multiplied by, but this time it is not 0.75 square, but it is minus 0.25 square minus of minus 0.75 square. Okay, so I'll just show that minus 0.25 square minus of minus 0.75 square. Okay, so how many brackets? So it is 0.5 into, okay, wait, let me check this. Okay, so it is, how many brackets I open for this? It is this one. This closes with this, and then this closes with this, and this should close with this. You see, 0.5 into, this is so it is 0.025 here. Sorry. So this is not in square. Actually, the square will always cancel the signs. So what I'll do, I'll just remove the minus signs. Okay, it is actually the square of that sign. Okay, so where else?
We got the
0.25.
P matrix.
Yeah.
We got the P matrix.
Yeah, we got the B matrix, but the answer is wrong. And just a second. This is 0.25 square minus 0.25 square. This is 0.25 square minus 0.75. This is 0.5 into okay. So here the one bracket was missing here. So what I've done is it is actually the square of it. Since you're taking square, the values I said it is minus 0.25. If you take the square of that, it will be again plus only. Okay, so I directly entered it as 0.25 itself. Okay, I have not taken it as minus 0.25 when I am taking the top layer. Okay, so when I am taking this 0.25 square minus of minus 0.25 square I should take, and then when I take for this layer it is minus 0.25 square minus of minus 0.75 square. Okay, so that is how we are supposed to take, but I've already removed the negative signs over here because since you square it, the negative sign turns into positive. Negative into negative is positive. So I have removed that. So this is there was a bracket missing in the starting. So that's why you were getting the B matrix different. Okay. So this is the formula for that. The B matrix. This is what we have implemented in that 1 by 2 into the summation of the all the reduced stiffness matrix, transformed reduced stiffness matrix multiplied by hk square minus hk minus 1 square. So this is what the B matrix formula, and that is what we have implemented over here. Okay, so let's do the D matrix now. It is 0.5, no, not 0.5. Now let's look at the formula. It is 1 by 3. Okay, it is 1 by 3 multiplied by it is cube here. Okay, hk cube. So here we need to take care of all the signs. Okay, I'll just copy this, paste it here, but I need to take care of the sign now because it is cube. So the negatives have to be taken care of. I'll just change from square to cube and then come back to the signs. Okay, squares are changed to cube. Now where all there will be a problem. So this is minus here, and then this is minus here. Okay, and then there is a minus over here. Okay, so these are the top portions, so minus. Okay, these are bottom portions only. So let's calculate this. So you get this D matrix as this. Now let's check if this is correct. B matrix is 0, okay, and D matrix is GPA mm cube because it's cube. Okay, mm cube, the formula has cube there, so that's why mm cube, GPA mm cube. 49.3482, 49.35, okay, 0.8148, 0.8146, okay, 00, I think it is fine. Okay, so this is how you calculate the ABD matrix, A matrix, B matrix, and D matrix for a given laminate. So what you need to understand is this is a sign convention. So take the midplane as z equal to 0, and from there you put the coordinates. You know the thickness of each layer. Thickness of each layer is given. Okay, that's a given data in the problem. Okay, thickness of each layer is 0.5 mm. This is the given data. Okay, so with that data you can calculate the coordinates, put positive downwards, negative upwards. So this is the sign convention that is followed here. So and then what you do for A matrix, there is no problems with the sign and all. Okay, it is only the thickness. So just multiply the q bar of 0, q bar of 90, and q bar of 0 with 0.5, the thickness of the each layer. Okay, you multiply that. For the B matrix, what you do is you have a half here. Okay, half. So for that you put a 0.5 here, and then q bar 0, and then this one is taken like this, 0.75 square, okay, minus 0.25 square, okay, And then for the next one, it is 0.25 square minus of minus 0.25 square. Okay. And then for the next one, it is minus 0.25 square minus of minus 0.75 square. So this is how you have to go for this. Okay. So then you get this B matrix. For the D matrix, it's simple. For B matrix, even if you make a sign mistake, it will not give you a wrong answer because you're taking a square of that. So even if you make a sign mistake, it's okay. It will be just the square. Just a second. Just a second. Yeah. So for the D matrix, you need to be a little careful. So it is 1 by 3. Okay. And since there is a cube here, you need to be careful with the signs now. Okay. For the first one, there is no problem because it is all plus over here, 0.75 cube minus 0.25 cube. Okay. So there is no problem. For the second one, it is 0.25 cube. So this is 0.25 cube minus of minus 0.25 cube. Okay, so you should not leave this minus here. That's important. Okay, and then for the last one, it is minus 0.25 cube minus of minus 0.75 cube. Okay, so that is what we have done. For the D matrix, please be careful with the signs because it's cube. So if there is a mistake with the sign, then the answer will be wrong. Okay, so for the B matrix, even if you make a mistake, it's okay because it's squaring off. Yes, any questions? So I'm just, we just discussed the importance of ABD matrix, the coupling and all these things we have discussed. And then we use some website link where we can calculate the ABD matrix directly. But today we just saw how we can calculate ABD matrix by ourselves using a MATLAB program. Okay. So suppose if instead of 090, okay, if this was 09090, okay, for example, I'm saying 09090, then what would have happened for the A matrix, B matrix and D matrix? 09090, what happens to the A16 and A26? 09090.
0, sir. The A26 will be 0, sir.
A16 and A26 will be 0 because it's a still a cross ply laminate.
Only 0 and 90-degree laminates. So,
Yeah, okay. Suppose if I change for this also, the B matrix 09090, then what happens to the B matrix?
0 only, sir.
B matrix will be 0. 09090. What is the condition for B matrix being 0?
it must be symmetric.
Yeah, 09090 is not symmetric, no? Okay. 09090 is not symmetric. 090 is symmetric. But 09090 is not symmetric. So let's look at this. Let's run this. I've changed the values now. So it is giving the ABD matrix. So as we expected, since we use the cross-ply laminate, A16 and A26 is 0, but B matrix is not 0 because it's not a symmetric laminate. 09090 is not symmetric. Okay. and D16 and D26 is 0 because it's a cross-ply laminate. So I did a small change with the 090. I changed it to 09090 and checked that the B matrix is not 0 now. Okay, so there is what type of coupling?
Bending extension coupling.
Okay, the bending extension coupling will be there. Okay, so I want you to try calculating for one of the laminates, the ABD matrix. Okay, so we'll give some assignment on these things, 1 or 2 assignments, so that you can calculate that and submit it. So you'll be assessed based on the assignments only, these things. But there can be a theory question like explain about ABD matrix, the coupling effects, and all those in the exam. Okay. So the transform compliance or the transform reduced stiffness, you'll not be asked to calculate in the exam, but you will be asked a theory question based on the understanding of the concept. Okay, but for the assignments, you need to calculate these things and submit. All the assignments for this particular module has to be done in MATLAB only. Okay, so it has to be done in MATLAB, and you need to submit that. So what I'll do, I'll assign different laminates for each student. Okay, and so that probably there won't be much of copying. Okay, so I'll just give some fiber orientation, change the fiber orientations for each student, and ask them to calculate the ABD matrix and submit it. So I'll just give that assignment, and then you should be able to do that. Okay, so any questions in this? Any difficulty? Are you all getting familiar with all these terms?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. So what I did was just made you understand what is ABD, and then showed you a website link where you can directly calculate those, and then showed how to do it with MATLAB. But with MATLAB, I have not gone to a very high level of coding because I don't want it to make it as a black box. Okay. So the MATLAB code must be very clear, and you must be able to understand what you're calculating with what. Okay, so that's how I've written the code. It's not very much optimized, but it's good if you write it like this. It will be helpful in learning, because I want the MATLAB to be helpful in calculating all this Q bar and all. Okay, suppose the laminate sequences say 0, 45, 60, 90, then you need to calculate for 0, 40, you don't need to calculate for 0, but 45, 60, 90, you need to calculate Q bar for all these three. Okay, so making hand calculations will become very difficult and very lengthy. It's not difficult, but it's lengthy. Okay, so use MATLAB for these things, and try to calculate the A matrix, B matrix, and D matrix by yourself. We'll give some assignment on this in 1 or 2 days, and then you can do the program and submit. I'll post this code in the Google Classroom. My only request is please don't copy the code. Copy paste is not going to help anybody. So please type the code, make mistakes. It's okay, it gives some errors, but try to correct those, and that's how we learn. Okay, just copy pasting the code is not going to help. Okay, so do that, and yeah, thank you. We'll stop it here. Any questions?
Thank you, sir.
No.
No, sir.
No, sir.
Okay, thank you. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.